Please take a seat. Today is the open day. We are happy to receive more than 240 guests from Finland and 39 other countries. I will give a short overview of our day. And so we have a plenary session called AI in STEM Education. Then we have info sessions by the STAIR area, by the Finnish National Agency for Education and STEAM Turku. It will take place 10:45 to 11:15 a.m. Then we're going to have a lunch break. Great, now you can see it. So we're going to have a lunch break. As you can see, first we have AI in STEM education. It's a plenary session. 10:45 to 11:15, we have info sessions by the STAIR area, by the Finnish National Agency for Education and STEAM Turku. At 12 to 1:30 p.m., we're going to have lunch together. Then we're going to have lunch talks in the STAIR area. And after that, brainstorming sessions will take place. We will have it from 12 in the noon to 1 p.m. One of the sessions is called EU Code Week. It will be in room Ivor 2002. The second brainstorming session will be in primary education, Eric 2003. After that, we have workshops from 1:30 to 2:30 p.m. Lastly, we have a highlight session, 5:15 p.m. to 6 p.m. And then we have a dinner in Koulu. Please see the app for directions. We will start at 7:30 p.m. All of this information can be found in the app, so please have a look. And now to today's topic, AI in STEM education. This topic is really important for many of you teachers here. AI is something quite new to many of us, but even more important to integrate early. Today, we will talk about AI from different perspectives. Firstly, from a university perspective. Secondly, from a company perspective. And lastly, from a teacher's perspective. Please come on stage, Linda Mannila, Associate Professor from the University of Helsinki. And now, let's hear her perspective.
Thank you very much. And well, a warm welcome from me to all of you as well. I just told my colleague here that I work at the University of Helsinki now, but this is my alma mater, so Abo Akademi University, where I did my PhD and my master's. We had our education here, so it's really nice, and I don't think that I've ever seen this aula this full before, even though we had all our exams and everything here. So it's really, it's a beautiful site from this perspective as well. I only have approximately 15 minutes, so I won't tell too much about myself, but I'll go straight to the topic. So AI in STEM education, or AI in education as such, is of course, as we already heard, a topic that lots of people are thinking about today. AI is not new. It's something that we've been dreaming about, talking about since the 1950s. But of course, when we had the generative AI boom starting in November 22, that's when we actually started talking quite a lot about AI also in education. Maybe firstly from a cheating perspective, but now also more looking into the opportunities, what are the new possibilities that the technology brings, and also then what are the potential consequences that we need to also consider. I've been working on digitalization, digital competence, programming, computational thinking in education, starting from primary to university level education for about 20 years. That says something about how old I am as well, I guess. And I thought that I'll start there just to give a perspective of how did we end up where we are now, and then give a glimpse of a project that we're working on together with colleagues from the University of Helsinki and also then Abo Akademi University. So early, or in the 1980s, up until the late 90s, we actually had computer science in the Finnish natural curriculum for basic education, grades 1 to 9. And that's something that was quite common in most countries, that we actually had some basic computer science there. But then as we got a lot of new tools and everybody started using computers more and more, decisions were made that, hey, it's not that important to learn about the technology anymore, it's more important to learn to use the technology. So we started talking about IT as a theme that was to be used as a tool, so integrating IT in different topics and subjects. Then 10 years later, there was a new boom that also happened globally, because now we realized that, hey, technology is actually affecting us quite a lot. We need to learn about it as well. So that's when we started seeing, in the 2010s, in Finland, it happened in 2014, we got a new curriculum that integrated programming and digital competence in the curriculum. Not so that we got a new subject, but it was done in a cross-curricular way. And some of the questions that were deemed important at that time, so this is by Marcus Deal, a researcher in computing education. So he brought forward several perspectives that were deemed important at that time. So this article is from 2015, and of course, given 9 years later and everything that has happened, it can be considered old, but still these same questions are important today when we look at the technology development. What do we need to understand about computers or about technology? What must we do to put the computer to work for us and not the other way around? How do computers or technology shape the way that we view our world? And what are computers not good for? What shouldn't we use technology for? A very important conversation to have today when we have these tools that could basically do more or less everything for us. And what should we actually teach to learners at different stages about this technology? So this discussion was had already in the 2010s, but then mainly in relation to programming. So programming was introduced in different curricula, and we're still working on that today as well. But then, of course, 2022 or 2023, depending on how you look at it, there was the rise of, if you want to talk about the rise of AI, rise of generative AI, or the development that actually put AI on everybody's lips. And then the question is, okay, so what should we do about this? What do we need to do now that we also have this new kind of technology, which basically is still programs, right? AI is nothing else than computer programs that can do things for us. But it's a different kind of program. How many of you have programmed or taught programming? I guess I will see quite a lot of hands. Yes, more than I usually see. And of course, if we think about how we teach or do ordinary programming, we usually talk about algorithms, right? Step-by-step instructions on how to solve a problem. But that also means that then we need to have a well-defined problem, because we can't write a recipe for how to do something if you don't know what we want to do. So if you want to make some kind of bun or a cake, then we need to know what kind of cake we want to do in order to actually go about doing it. So when we talk about ordinary programming, we need to know what are we solving, what are the situations that we need to address, and what is the data that we're looking at. How does the data, what does it look like? And we usually talk about this as rule-based programming. So it's something that we do that actually follows a set of rules. But of course, all the problems that we see today in our society aren't well-defined. We can't say that, okay, so these are exactly the measurements that we need to take into account if we want to predict earthquakes, for instance. What are the actual aspects that we need to look at in an X-ray image in order to make sure that we give the right diagnosis? And more, we also have a lot of data which we as humans can't. We can't be sure that it's structured because we can't get an overview of all the data we have. So then we need another type of program which can solve these complex problems, deal with unexpected situations, and also deal with unstructured data. And that we could talk about data-driven. And that is where AI comes in, because this is what is made possible by AI. Because we can have these programs that don't necessarily react only to the rules that we give, but base a lot of the decisions on previous data. We can choose what data to use, and then the predictions and the decisions can be made based on what's learned from that data and the model that's been built. And for those of you who are interested in learning more about this perspective, there's actually quite a good paper from 21 by Matti Tedre and colleagues on CT 2.0, where they basically argue for that if you look at computational thinking in an AI society or an AI world, we need to make sure that, or we need to look at it from another perspective, that we can't only look at it from this rule-based perspective anymore. We need to have new ways also on looking, for instance, at programming education, that we need to take into account that data plays a more and more important role in how we solve problems in the future. So for instance, going from formalizing the problem to actually having to collect the data. And then instead of writing these rules, trying to come up with, okay, so how can we use this data to create a good as model as possible in order to solve the problem at hand. And so when we look at this, we have this, basically we have this new type of programs that we need to learn about. We need to be able to handle AI in some way. But the most discussion on AI in education has circled quite a lot around this perspective of learning with AI or using AI, which is quite understandable given that we have these very practical tools now from generative AI, like ChatGPT or DALL-E or Copilot, and all of these applications that makes it possible to create, use, learn in quite new ways, or totally new ways. And of course, it's important to learn when to use these, how to use these, but also when not to use these tools, and also how not to use these tools. But AI is not only generative AI, it's a lot of other things as well. We have recommendation systems in social media that form our view of the world. We have a lot of data being collected about us, raising a lot of questions related to privacy. So there are a lot of other questions as well that we need to deal with. And of course, they go somewhat into this perspective as well. But I think that it's important that we also, again, going back to the computational thinking slide by Gus Deal, we need to also learn about AI. So again, what kind of competencies do we need in relation to AI? And of course, there's a lot of discussion, I think, at least in many of our countries, about do we actually, how much technology do we want in schools? What are the problems of social media? Do we actually need to do this? Couldn't we just go back to books and paper, pen and paper? But I also think that it's important to remember that regardless of whether we have technology in schools or not, whether we use generative AI in schools or not, when kids and youth leave the school buildings, this is the reality that they are living in. And these are the questions that they are facing, and they will be facing also in their future life. So learning about AI, learning the foundations of what is it actually, how does it work, what are the pros, what are the cons, is as important, I think, many others as well, as having this basic foundation, digital competence as well about the digital world. And this is usually coined AI literacy. How many has heard that before? Quite a few hands there as well. And of course, we have a lot of literacies. I think there are as many literacies as we are people here today, because it becomes so easy to come up with yet another literacy, and I think that was with computational thinking as well. What's the difference between computational thinking and mathematical thinking? But basically, AI literacy has been used as a term to define what are the competencies, the skills, the knowledge, and the attitudes that anybody needs. Not those necessarily who want to work in the field, but those who live in a world where AI is quite prominent. And this is one of the frameworks that has had quite an influential impact by Long and Magerko from 2020, where they list 5 different areas in which you then also can have these kind of different activities or the things that you should consider. So what is AI? What can AI do? What can AI not do? How does AI work? What should AI do? What should AI not do? And how is AI perceived? So these are basic questions that we should think about when we teach not only young kids, not older kids, but everybody, because this is also a challenge that when technology development moves forward, of course, it's not only kids and youth who need to be thought about it. It's, well, more or less everyone. So that's a big challenge, and I think that schools are well prepared in that sense that youth and kids, they will probably be fine. I see bigger concerns maybe with the older ones as well. And this is a framework that we have been using as well in a project that we're working on, co-designing lesson plans or co-designing activities to use in the classrooms for teachers. So we're doing it with students, teachers, teacher trainers, and IT educators based on the Finnish curriculum, where the idea then is to try to come up with some kind of not a ready-made answer, but something that would be enough to cover AI literacy in a K-12 Finnish context. We also have a similar project in Sweden, and there we are also doing a Delphi study on trying to get a multi-perspective view on, okay, so what could actually AI literacy mean for kids at a certain age? Because, of course, this framework is very, very general, and having a general framework isn't easily translated into actual classroom practices. But so this ILIT project that we have in Finland, we then deal with student teachers, teacher trainers, curriculum, do it in several phases. And doing so, we've ended up with having 3 lessons or 3 materials that were basically 3 hours per year for teachers to work on AI literacy with their students. And 3 hours doesn't sound like much, but everybody who's a teacher, given almost everybody here, knows that the schedule is usually quite crowded. There's usually not that much place there. And something we learned from introducing programming as well, and what we've seen in our studies, is that when programming was introduced, there was a lot of material presented as well, which is of course, a very, very good thing, that there are lots of resources for teachers to choose from. But at the same time, for teachers who were not acquainted with the material from before or the topic before, it was really difficult to know what to pick, what to choose from, what should I start with. So here we sat down with teachers, talked to them, related back to what they had been doing earlier, and then tried to also come up with, okay, so what would be a suitable number of activities or material that you could actually do and your colleagues could do without taking too much time and without requiring too much effort. Of course, effort is always needed, but to make it as easy as possible. So that's been the idea in this project all along. And then taking in the student perspective and also the teacher-trainer perspective, because of course they are then quite important when we think about the in-service or pre-service teachers, so those who want to become teachers. So the first one focuses on what is AI, what can AI do, and how is AI perceived. So quite a lot of discussions there about what are students' preconceptions, what do they think AI is. Some students know a lot, some of them don't even know what the term AI stands for and try to see it as some kind of escape room activity, trying to come up with what does A stand for and what does I stand for. Where do they find AI? Some students tell about how they are frustrated with Snapchat's My AI because it doesn't get angry. So it starts when they try to make it upset. It just goes on like, oh, I hope you have a very nice day today. Do you want to talk about anything else? And that's not how a friend should work, like, right? A friend should also get upset every now and then. We have students who are saying, 8-year-olds, like, yeah, I kind of like AI myself, but I'm kind of worried about my parents because they work in theater, and all the news now tell about how the creative sector is affected by AI. I don't want them to lose their jobs. So kids, even 8-year-olds, think about these societal questions as well. So this has been very, very important in actually getting some sense of what kids know, but at the same time also trying to address potential misconceptions, etc. And then the other one is going more into how does AI work. And an important part of AI literacy is that you don't necessarily need to create your own AI tools or AI solutions, so you don't necessarily need to be able to program them, but that you can actually understand how to build a model, how to use data to solve a given problem. So I have a bigger slide of this as well if you want to end the presentation. But that's a tool that's been developed also at University of Helsinki and the University of Eastern Finland in a big project called Generation AI. It's called a teachable machine. Google has one as well, but this is GDPR safe, so you can actually use this and no data is stored anywhere. So basically you could create a feelings machine. So I upload a lot of faces or webcam pictures of myself smiling, and then a lot of images of myself being sad, and then I can train my model, and then you could add your own face or just show your face to the camera, and it can say that are you happy or are you sad. A very interesting, very fun with kids, because then they want to try their colleagues' machines as well. And then the final one deals with the ethical considerations. We look at AI-generated images of classrooms with students their age in a Finnish context, and then we discuss, is this actually a reflection of what our classrooms look like, etc. Try to be AI detectives and look at different type of AI materials. And this is, if you are interested in trying out the machine, then I put the link there as well. And to finalize, So this is something we're doing with schools, with teachers. But of course, if we look at the big picture and we look at AI in education, learning with, learning about, we can do quite a lot at the classroom level. But we also all know that, well, if we want an equal education system, if we want every student to have the same opportunities to learn, there has to happen, things has to happen not only on teacher-student level. We want some equality within the schools, right? So we need to have some development at school level. But then we also need some development between schools to make sure that there actually is some kind of, are some requirements or some regulations or guidelines on, okay, so what should we actually teach about this? What do students need to know? And then finally, curricula, but then also values, politics, culture, all of these play of course, a role in how AI-ready schools we then have for what we have today, but also then the future, because as we probably all know, technology, we've never had as poor AI solutions as we have today. So I think that's a good thing to remember as well, that we will see new things in the future as well. Thank you very much. It was a pleasure being here.
Thank you, Linda. And now, let's hear the perspective, which is probably the most interesting perspective for all of you, the teacher's perspective. Please welcome Claudia on stage. She's a primary school teacher in Portugal and has a master's degree in ICT in education and training.
Hello. I'm just, wait a minute. So I'm going to start by this presentation by thanking Science on Stage for inviting me here.
Hi there. My name is Alex, and I'm an AI assistant. I'm here to welcome you all to the Science on Stage Festival in the beautiful city of Turku. We hope you enjoy this AI and STEM education session with Linda and Claudia and feel inspired. I love this topic and I could talk about it all day. Really. All day. But now I'm going to pass the word on to Claudia. Have a great day. Bye.
Thank you, Alex. So I'll take it from here. So Alex was created with a Gen AI tool, Synthesia. And now, like Linda said, we have lots of these tools available for us to use. And we may classify all these AI tools in 3 ways: system-facing tools, teacher-facing tools, and learner-facing tools. So the teacher-facing tools, like Wayne Holmes said, are built to help teachers become super teachers. They give us superpowers. And we have here a room full of super teachers, so if you have these tools, use them. And we also can decide when and how to use these AI tools. So what is the superpower? We may control time. We are always complaining of work overload, that we spend hours planning, writing, preparing lessons. So with these Gen AI tools, in a matter of seconds, a lesson plan is created, a presentation. We may develop assessments, quizzes, tests. We may grade all these endless tools that we have now. The tools we have today, they are already out of date for tomorrow because, as you can see, Gen AI tools appears every day, and this is growing exponentially. Here I have some examples. that you may use, and some of them you already may know. Yesterday on the AI Tools for Teachers workshop, we explored some of them. We have chatbots like ChatGPT, Claude, Copilot, Gemini. I only put here 3 examples for each. We have platforms already designed for teachers that facilitates the prompting, like Magic School, EduAid, School AI. We have presentation tools like the one I used with Alex, Synthesia. Gamma is also a great tool. I want to tell my participants of the workshop that this one is also good, and I intended to present it yesterday, but we didn't have time, so explore it in the Padlet, please. To design, image, Microsoft Designer, DALL-E, all these examples. To create video, also one that I adore, this LUMA-AI, also has the same name of the center. To create music, this tool, Suno, for example, it's a wow tool. You just prompt, a simple prompt, and then in a matter of seconds, you have the lyrics, the music, the voices, everything in a song. Oh, sorry, I didn't pass that one. Well, okay. So when I talk about AI in the primary classroom, some people say, primary classroom, isn't that too early to start talking about these subjects? And I answer as follows. Our students in the primary classroom age use tools, AI tools every day in games, toys. They are already digital content creators. They create videos, they edit images. And aren't they using already Gen AI for their homework? They interact naturally with virtual assistants. And also, one thing that we must be aware, they provide personal information without knowing, because it's a natural interaction. And that's why it's really, really important to start AI literacy in early ages. So now I'm going to tell you about this plan I made for my students. This was a case study during my master degree. So I implemented this planning for a 4th grade class in the school year of 21-22. It was before the boom of ChatGPT, and we were already teaching AI in the primary classroom. So we made a plan, and the students programmed AI in PictoBlocks with the PictoBlocks distinctions of machine learning, computer vision, and natural language processing. So we had to adapt all the materials to the age level of the students and use diverse disciplines in PBL, and we used free resources online. I also elaborate some resources like worksheets and tutorials. They are all available for free online. We made an ebook with all this content, so you can access for free. You just Google me, Claudia Marinhos, ebook, AI, and you have access for free. So all of this occurred in 5 phases: preconception, knowledge, ethics, skills, and assessment. In the first phase, I interviewed my students to know about their previous knowledge about AI. And I asked them to draw what was AI for them. And we also played the game Keynote. And at this preconceptions, my students, some of them associated AI with everything involving technology. All technology was AI for some. Some of them said it was the internet intelligence. In their drawings, they've drawn many robots and electronic devices. And some students believe that robots had a brain and they can think and have emotions. And about virtual assistants, they thought that were real people responding live. And for some students, that AI assistants became their friends. Because they said, oh, teacher, when I am sad, my assistant sends me happy emojis to make me happy, so she's my friend. And some students also thought that the game Akinator was magic and had superpowers because it could guess their mind. So in the second phase about knowledge, they learned about what was really AI. And we saw some videos at first, and we analyzed them, we made debates about it. We then had an activity about cats and dogs and to learn about databases and the importance of data and the large amount of data that is needed to train these models. Then the kids interacted with AI in different ways, and we used these free resources online, training, drawing, painting, speaking, and playing. In the third phase of ethics, we explored this activity in the Code.org platform, AI for Oceans. In this activity, the students had to train AI to distinguish between what was fishes and what was garbage. So they click, this is fish, this is garbage, this is fish, this is fish, this is garbage. But then ahead it appeared a different fish, and the AI considered it garbage because it wasn't trained with that information. So they were shocked. And they said, oh no, teacher, we have to protect all fishes. And that's when we discussed the importance of the data bias and the discrimination and ethics in AI. So in the fourth phase, they programmed this tool, PictoBlocks. It's like Scratch. They worked in groups, and they trained the AI models in the Google Teachable Machine. They were free to choose their topics about it. Some groups choose mathematics or science or music. We have there the Beatles. Or games like Roblox and Minecraft. They train these models with computer vision, with their voices, with images and sounds. So at the end of all of this, we analyzed the evolution of their conceptions. And at the final phase, I just chose these three ideas, and on their own words, one of my students said, AI, what is AI? Algorithms that learn from data put in by humans. And what about robots? Do they have a brain? We do the programming, and they don't have a brain of their own to think with. And ethics. This is what I consider even more important. One student said, I think it should be an experienced and good person who doesn't put in bad data. And with this phrase, they learn all about it. Here in the drawings, I chose some drawings for you to see the evolution too. It's the same, the initial and final drawing of the same student. So this student at the beginning, he was trying to guess, and he was drawing everything that you remind, because he wanted to be right. So he was drawing, is this teacher, this is AI? Or this is, what about this? So he wasn't sure. But at the end, with this drawing, he drew a robot that has data, that has algorithms, that was programmed by the human hands behind it. With these other drawings, we see that this student in the initial drawing, he already designed a robot linked to a computer being programmed, perhaps. But at the final drawing, he thought that the best use of AI is to help to clean the ocean. So we have to start exploring these themes with our students of all ages. Green AI, it's a concept that we have to explore, because we all have to be aware that to train these systems, are wasted a large amount of natural resources. And AI for sustainability, and above all, AI for the good of society. So all of this led for me to create my project that I have here at the festival, EcoKids Teach AI. So I transform my second grade students into superheroes of nature. And they had this mission to learn all about recycling and separating garbage in the correct recycling bins. And then they had to teach, like they had to train AI to do it so. And this project is also in the AI and STEM materials that Nadine is going to talk about it later. So I made this presentation video for you to see.
Hello, I'm teacher Claudia Medeiros, and these are the EcoKids, superheroes of nature. Welcome to our world. They received the mission to learn all about recycling and sorting rubbish, and train the artificial intelligence to do the same. Their mission started at home. At school, they learned with games and robots. They also visit plastic recycling plants. They learned about AI for their ally and trained her to sort the rubbish correctly. By training AI for the good of humanity, the EcoKids mission was a success. EcoKids Teach AI. Bye! See you soon!
So their mission was a success. And now I finish my presentation. Thank you very much for your attention.
Thank you, Claudia. Now we are going to go over to how AI changes future jobs. Let us show a short video greeting from Michael Vollman. He represents Amazon Future Engineer, supporter of the project AI in STEM Education.
Hello from Berlin to Turku. My name is Michael Vollman and I work with Amazon Future Engineer, a philanthropic educational initiative with the goal to prepare students of today for the careers of the future. How we do this? Well, we work with many non-profit partners like Science on Stage in 3 categories. First, we offer career exploration assets like class chats, where industry experts from Amazon and other companies provide insights into their day jobs, but also in their biographies and the challenges they had to overcome there. We offer virtual field trips and career tours to our fulfillment centers and to our data centers to show how technology is already applied in logistics and in cloud computing. We explain basic AI concepts like cloud computing and generative AI and large language models, and we show careers behind those future technologies. Secondly, we want to train teachers with future curricula in coding, in project-based learning, in Python, and also in AI, like the teaching materials that you will now see and apply. And third, we provide scholarships and bursaries to students from underserved backgrounds to access IT bachelor studies. All in all, we're operating in 5 European countries: UK, Germany, France, Italy, and Spain, but we have many funding models and materials available for other countries as well. So please go and check it out on amazonfutureengineer.com in your respective country. Thank you very much for being so open-minded to learn something new about generative AI that will play a very important role for those students today in their careers. Because the jobs that will exist tomorrow are as unknown to me as to you. But we know that future technologies like generative AI will play an important role there. Thank you very much and have fun today. Next time I hope I can be with you in person. Bye.
We already heard about the new teaching resources, AI in STEM education. AI in STEM education is developed from teachers of the Science on Stage network. Please welcome Nadine, Project Manager of Science on Stage. She will give us further information. Thank you, Nadine.
Thank you. Welcome from me as well. It's great to see so many people here about this exciting topic that Science on Stage has been working on for about a year now, and we have published these materials, of which you have seen one just presented by Claudia. These are 5 projects that are published as digital materials, and we just put them online last week. So this is really the premiere of these materials, and we are very excited about it. And we'll have 2 more of our authors. Like we had 5 teachers from different countries, and 2 more will be here and will be presented to you shortly. You saw a bit yesterday about the Science on Stage digital materials, what they provide, how they are arranged at our website. They are available in English and German. And we have a short clip to introduce the 5 projects. Yes, so as you can see, we have material for all levels and ages. You can choose different activities. You can choose coding projects, either for visual programming in Scratch or Pictoblocks, or for more advanced students with Python. And you can have all kinds of tutorial videos, templates for use, for example, rubrics, evaluation grids. So please check them out. We also have resources for career orientation. We assembled, and this is an ongoing project that we will add to also. With your input and feedback, we can develop these resources more. And because we have the chance of having the authors themselves here, I mean, this is a project, as all Science on Stage projects, from teachers, for teachers. They are also all peer-reviewed and proofread by teachers. So I will briefly introduce the two other projects that we can present here. So this one has a short screen video. We will just scroll through for you. So you see on our start page, you can go to the teaching materials. And the AI in STEM education has a start page for the 5 projects. And this one is on machine learning. So here you get a really thorough introduction to how artificial neural networks work, how you can set them up yourselves, design them yourselves, train it with testing data, with training data, you test it. And you have all kinds of interactive elements that you can enter data and see how does the network learn, why does it make errors, how do I minimize those errors. And these are animated so that actually the students and you yourself can try out for yourself how to minimize an error, how to classify things, how to find a separation line. So these are really a lot of chapters that you can go through and explore also different applications of machine learning, like text, like images. And then you have your own tool to use your data and create a neural network. The other project that we will present today is more project-based on combining recycling smart, it's called, about coding a smart recycling system. We also have a short screen video for that, so that you see how it is set up. This is a project that was actually in the final of the Future League, a competition organized by Science on Stage. It is developed by a student-teacher team from Turkey, and you can get information and code examples and all kinds of step-by-step guides on constructing the smart recycling system, and also find some more ideas on how to integrate the community into this project. Maybe setting up your smart recycling system in a nearby kindergarten or senior home. So this is also a very nice resource to use in projects reaching out to the community. So these are the projects that you find on our website. And we will now hear from these two teachers on stage.
I am very happy to have two of the authors of the material here in Turku. So let's welcome on stage Selçuk and Daniel. Come on up here. Okay. Selçuk Yusuf Arslan. He is a computer science teacher. He has written his doctoral thesis on STEM policies for achieving the UN Sustainable Development Goals. His project, Recycling Smart, was developed as part of the elective course AI and Machine Learning. This was done at the Atatürk Vocational and Technical High School in Ankara, in Turkey. It has received numerous awards with its interdisciplinary approach to AI and sustainability. Daniel Jansen. He teaches ICT and physical education at a high school in northwestern Germany and has a PhD in sports science. His extensive digital material on machine learning in school goes back to a project that was presented at the Science on Stage Festival in the year of 2019. It will now make its debut in English with more than 600,000 characters and a lot of code later. Now I have some questions for Selçuk. Why is it important to teach students to apply AI machine learning themselves?
First of all, I think it is important to have AI literacy for every student because every professions in the future will use AI, and it is very important. And on the other hand, some students may pursue an AI career. It is different aspect, and these students should have AI information and skills, AI knowledge and skills, and they should know some statistics and programming skills, and then they should use data analyze and visualization, and they should know machine learning, etc. This is an interdisciplinary approach, and if they know these skills, I think they are one step ahead in the future.
What technologies do the students use in the projects?
I will answer this question according to Recycling Smart project Nadine mentioned. In this project, we have an elective course, Artificial Intelligence and Machine Learning. In scope of this lesson, Recycling Smart is learning outcome. And the students code in Python, students took robotics lesson before, and they completed this project by using Raspberry Pi. Firstly, they use ready-made models, but this is not enough. After that, they train their own models, and I think it is very important and a good level for high school students. And at the end of the project, they focus on many subjects in the curriculum.
As a teacher, does artificial intelligence reduce your workload?
Absolutely, yes. As a computer science teacher, I use some generative AI tools in order to teach coding my students. Last year, we conducted a project with my 3 volunteer students, and we focus on how can we teach coding with ChatGPT. And we prepared a booklet, not we prepared, ChatGPT prepared a booklet about teaching coding with Python. It was really impressive because when we give a subject to ChatGPT, it explains it really very well. I think the main conclusion is that when we give a code to ChatGPT with some errors, it fixes all of the errors, but it is not very good when which errors we experience. But ChatGPT uses internet and it will improve itself day by day. Moreover, we can use some AI tools assessment process. If we have a large number of students, we can save a lot of time, and we can use this time spent teaching, I think it is very important. As a teacher, we have a lot of tasks, and if we can use AI tools, we have more times for teaching. And in sum up, we cannot ignore artificial intelligence. I think we can use its advantages as soon as possible.
Thank you.
You're welcome.
Now we have some questions for Daniel. Firstly, AI courses are becoming more popular. So what is special and unique about your way of using machine learning in school?
Okay, the basic idea for me was to use no programming, just modeling and exploring models, because I think it is important not to treat AI as a black box. So if you want to understand what ChatGPT is, I think you have to look into the components. And ChatGPT is math plus multiple and several neural networks. So my project deals with neural networks, and you can explore all these components of neural networks, from neurons to learning, to backpropagation even, how it is done, but without programming and on a level so that you can explore and you can't damage anything. You can explore, you can play around with it. Everything is in the browser. And students even can train their own neural networks just visually by clicking them together, use their own data and see what happens. And I think this is maybe special or unique about it. Not use programming, but go into detail nevertheless. Okay.
So Daniel, you have developed the machine learning units over the course of several years. From your experience, do you have any tips on how to integrate the units into the classroom?
These units are made so that students can work on them alone by themselves, or maybe in pairs, or in kind of blended learning at home maybe. The most important thing about me is it's for teachers as for students as well, so they can discuss. After every chapter, I think you should discuss what you have learned. So if you learned that even a single neuron makes errors, you have to talk about these errors, and that neural networks then make errors too. And what do these errors mean? Or if you see you put data into these neural networks and your data is bad. So what does this mean? And are there many applications maybe that also have bad data? And then you can discuss it. And I think that's the most important thing, to make students able to judge on how AI works and what it means for us all. So bad data, errors, and these are not perfect algorithms, but there are data-driven models that maybe make errors as well. And I think this is important to learn for students.
Thank you, Daniel.
And teachers as well. Okay.
That's right. Give it up for Daniel. Okay. Concluding the interview with the authors. Both of them are available for AI courses. AI courses are becoming more popular. So what is special and unique about your way, how machine learning should be taught in school? Questions and demonstrations at the Science on Stage stand during the fair. And Claudia Merinhos presents her project, Eco Kids Tech AI, at her own stand, number Y6. Feel free to drop by and find out more about these innovative projects.
Yes, just to wrap up our session, we are already at an hour, so thank you for all your attention. But I wanted to make you aware of some offers that Science on Stage has in relation to this project. So we have a competition. If you have an interesting project related to AI, if you have developed or if you're inspired by the material to develop a project that uses AI in a creative way to find a solution for a problem in your community, then please hand in your applications for our challenge. And until February, the call is open, and the final will be in Berlin for 10 teams to find the winners of our competition in June. This is also sponsored by Amazon Future Engineer. And then, if in general you want to organize a teacher training, maybe with this material or with other topics related to coding, it's possible to get a grant. You can apply to the address or via the code that you see here. And of course, if you have questions, we are at the stand also to reply to these questions. Or you can get a small grant to support a teacher training activity at your school. And then, yes, we have some final announcements also for this day.
Yes, thank you, Nadine. We also offer AI webinars on October 22nd this year. And here you can find the QR code to register. Science on Stage material might also motivate you to participate with your ideas in the EU Code Week, which takes place in October this year. If you plan any coding activities, you can go to the EU Code Week webpage and register. And now, we need all of your support to motivate other teachers as well and help us out with a contest. This is a PR contest of different countries joining the Code Week. The most creative idea gets a small prize, and of course, we want to win it. And I am sure there's no other event with teachers from so many different countries. I will count 1, 2, 3, and then we all say, join the EU Code Week. Okay, are you ready? 1, 2, 3. Join the EU Code Week. Great. Now enjoy the fair. We will see each other at 5:15 p.m. for the highlight session.